Okay, here we go. Are you in the right place? Okay, so this is me, Mark Ashbrook. You can call me Mark. I'm fine with that, or anything respectful. You can call me Dr. Ashbrook, but I'm not a doctor. So, but that's fine, I guess. All right, these are our TAs. That's Roy, first in the blue shirt, and Kirk in the hat. And these are going to be your best friends this semester, okay, to help you get through the course. After me, of course. So there's the three of us, and then there's also other TAs, other instructors who are going to give you their office hours as well. So hopefully throughout the week, there's all kinds of times when you can get assistance. Many of you may have, you breezed through math classes your whole life. Well, that may come to an end this semester. You're going to have to get help. This is a hard course, okay? So you're going to have to get help, but we're trying to offer all that support for you throughout the week. But all of you will have either Kirk or Roy for your TA on, I think it's Tuesdays. When are recitations? Wednesday or Friday. Okay, so you'll have one of these two guys. Calculus geniuses. Okay, so make them your best friends. Okay. So getting started here. So this is the best way to get a hold of me, is email. The easiest one, mark.a. Mark.ashbrook will work, okay? It takes to the same place, but mark.a. Okay? I check my email all the time, all day long. It's a really bad habit, but it's really good for you because I can usually get back to you pretty quickly. Sometimes right away. Okay, we said that, so we got Kirk and Roy. Those are our TAs. Those are their email addresses. Okay, so Blackboard is going to be our home base for the course. It's going to be where you get all the information that you need. So let's talk about that. The syllabus is there. One of your things to do for Thursday is to download, print the syllabus. We'll talk through it, but you should have it handy. You're responsible for everything on it. Okay, so written assignments are there. Other course docs, readings. Okay, so everything in terms of homework will be posted there. Okay, exam results. So I'll put exam results on Blackboard. Okay, I screen record every class. Okay, so everything I do will be through the screen, and then I'm screen recording right now. So what you see is what you see on the screen, and then what you hear is my voice, and sometimes some of your voices as well. So you get a full reproduction of class, and I'll post those on Blackboard later in the day. So hopefully, like by noon on Tuesday and by noon on Thursday. Okay? By no means is that an alternative to coming to class. Coming to class is actually absolutely essential. Okay? So this is for review. It's really critical that you repeat the material. You go through these questions and the things that we do in class. So the videos will be a great way to study. Okay, grades are on Blackboard. I'll be saying this often throughout the semester. Blackboard grades will try to compute an overall grade. It'll try to compute your total. Just ignore that. Wherever it says overall or total or summary, the only thing I use Blackboard Gradebook for is recording your individual scores. So when it tries to calculate some kind of overall or total or summary grade for you, that is not accurate because all the points are worth different. Okay, so just ignore that, and I'm sure I'll have to remind you of that. Okay, I will, like once or twice in the semester, I will put up this is your current standing in the course, and you'll know. I'll let you know about that. Okay, so you should have gotten some emails from me. I think 3 so far, or 2 or 3. If you haven't gotten emails, then you have to use your ASU account first of all, or if you use your ASU account, something's wrong. You should have gotten emails from me. One of the things I talked about was getting enrolled in Top Hat, and as of yesterday, it was still only about half of you. So I'm serious. Okay, do it. So you got to enroll in Top Hat. It's $20. Go to tophat.com. Buy your subscription for 1 semester, and then enroll. And I think here's our info. So our enrollment info is, sorry, this on here. So the name of the course okay. So actually, we're going to use it today. So we'll see if it works. All right, so the name of the course is S15 MAT 270. Or you should be able to find it by my name, Mark Ashbrook. One of those two should get you there. But many of you have had success enrolling, so I know it's working, and we'll try it out today. And we'll be serious about it starting Thursday. So we'll just do a trial version today. Okay, and so another thing I said in my emails was I want you to buy an 8.5 by 11 dry erase board and marker for class. Okay, this is one part of how I'm going to make sure you are active and engaged in class. Okay, with so many of you, we want to be able to monitor what you're doing, and so I'm going to be giving you little group assignments, little 30-second, minute, 5-minute tasks, and you should be writing and engaged and thinking. And then this is an easy way for the TAs and myself to monitor how you're doing, because we'll be able to see what you're writing. Okay? So last semester, with this large class like this, and a room that feels awfully like a movie theater. Okay? But this isn't the movies. You're not sitting back, kicking your feet up, and relaxing. But lots of people did that. So come ready to be working. Okay? So that means you're taking notes, so have a notebook to take notes. You've got your dry erase board, so when I give you a task, you're ready to write. And sit next to people that you can engage with and talk with. There'll be lots of conversation as well. Okay? So no sitting back and watching. That's not going to be permitted, and we're all going to keep you accountable to that. Okay, so eventually here, in the next week or so, we're going to be using a software called Graphing Calculator, and we'll call that GC. So whenever we say GC, we're talking about Graphing Calculator. It's a little bit unfortunate of a name because it's not a handheld calculator. It's a software for your laptop or your home computer, and it does everything a handheld graphing calculator can do, and it does it 100 times better, and it does 100 times more than that. Okay, so most students who really use this and use it a lot, they find that that's what now they want to use. They don't want to use a handheld anymore. Okay, so it's an excellent thing. It's free to you. It's going to be totally free. So this is a great benefit. And we will be doing assignments. I will be using it consistently in class, and then you'll have assignments where you'll be using it too. It's an excellent learning tool to help you stay up with your understanding of what's going on. Okay, if you're using that correctly, it's really forcing you to apply what we're learning. Okay, any questions? So we're going to I'm going to show you Blackboard and the syllabus here. Any questions about these things? Yeah. No, so not on tests. The tests are written so that just a handheld is fine. Yeah. Yeah.
So handhelds we're not allowed to use.
On exams, yeah, 89. Yeah, is that what you have? You'll be fine. You can borrow one. Other questions? Yeah.
It's on the syllabus. We can actually download it from there.
Yeah. So the download instructions will be on Blackboard announcements in the next couple days. I'll show you that in a second. I figured, yeah. Glad I could help. All right. So then these should be up here. So here's our home base, Blackboard. Maybe. The internet. They always like to, do something to make the internet in the first week of class, right? First week last semester for first week this semester. Okay, here we go. So on the announcement page on Blackboard, here's your task for Thursday. You're going to download and print the syllabus. We'll talk through a little bit of it today. There's a first assignment, a written assignment. I'll show you where that is. If you have not already, you're going to purchase your Top Hat subscription and enroll in our course. And if you have not already, you're going to buy a dry erase board and be ready, bring it to every class. Okay, and you're going to want some kind of eraser, so you're not erasing with your hand. Something like a cloth or some kind of eraser, as well as black markers and your board. So that's where you can find your startup task for Thursday. Okay, here's a question. All right, so the syllabus here, the first course link is syllabus, and that's where you can print it and download it. Readings and homework. You'll see your first assignment here is to, okay, so I'm going to post these readings that have questions built in, but just because I post that whole thing doesn't mean the assignment is to read the whole thing and do every question. Then you have to read here below the details. So here I'm telling you, read pages 1 through 3 only of Module 1, Section 1, and answer reflection questions 1 through 6 from pages 1 through 3. So if there is a page 4, 5, and 6 in this document, that's not part of your assignment. So although we're posting, these whole documents, you have to read below for the specific instructions about what your homework is. Make sense?
Yes.
Thank you.
Of course.
Okay, so let's look at the syllabus. I'm just going to highlight some important stuff here. Okay, so again, I told you that the best way to get a hold of me is mark.a@asu.edu. My office is ECA 209. It's less than 5 minutes from here. It's right across the street from the bookstore. So right across Orange Street from the bookstore up on the second floor is where my office is. My office hours are going to be Mondays and Wednesdays from 10:30 to 12:30. You can also email me to make arrangements for a different time. Okay, our recitation TAs, Kirk and Roy. I'm going to list all of our office hour information on Blackboards. Let me go back there and show you that. Oh, so there'll be a course link in here. It says office hours, and you'll click on that, and it'll have everybody that you could go to for help and when and where they're available. So I just encourage you to, if you forget and you don't know when my office hours is, go here. Okay, so it's kind of cumbersome when there's 100 and some people in a course, and I get the question, when are your office hours? 100 times. Okay, so it'll be posted. All the office hours information will be posted here in a link on Blackboard. Okay, so try to remember. Just if you want to know when they are, just go there. Okay. No, where are we at here? What was next? So syllabus. That's where we were. Thank you. All right. So course materials. Blackboard we talked about. Home base. Everything you need is there. Graphing calculator. We talked about that. You'll be downloading that soon. I'll put an announcement with all the info on Blackboard. Top Hat. We'll try that out in a second. Dry erase boards. Okay, web work. This won't be until the second half of course. Second half of the course we'll use an online homework system, so there's nothing to worry about there. I will give you all the details when it gets closer, but that won't be until March. Okay. Access to a printer. Occasionally you'll need to print stuff out, so to hand in. So just be aware of that. Here's the basic dates of the course, withdrawal dates, drop ads, spring break, final exam. What's that?
So it's at 7 p.m.
Yep.
Very well.
Yep. Okay, schedule of topics for the course. I'm not going to read this. You're welcome to read that. The exams are here. Talk about exams. We will not take exams in lecture. We'll take exams in recitation. We're going to take exams on Wednesday evenings in a different room, PSA. So I'm letting you know that right off the bat so you can make sure your schedule is clear. So the first one is February 4th. February 4th, 6:30 to 9, PSA 21. Now, probably won't take you that whole time. In fact, it won't take you that whole time. Okay? Test 2 is February 25th. Okay? Then we have mastery exams in early March, late March, early April. And then the last exam, Wednesday, April 29th. So I'm giving you fair warning. Okay, so yes, I know some of you have classes on Wednesday night. So you just let me know if you have a class conflict, and then we'll make other arrangements for you. Okay? Are there still questions? Yeah.
What are mastery attempts?
So a mastery is an exam. Oh. So this is also an exam, and we'll talk about that when it gets closer.
Okay.
Yeah. So there's 3-hour exams, and then there's the mastery exam, which we'll talk about later. Other questions about that? So yeah. So maybe in the next week or so, if you want to shoot me, or I'll send an email if you have and you can reply to that email if you have class on Wednesday night, and then that will generate a list. But watch for that email and please reply so I get the list of those of you who can't make Wednesday nights. Okay. All right. So homework, you can read through that. We're going to submit homework at the beginning of class. That's when it's due. No late work is accepted. I'll drop some at the end of the semester, but it's due at the beginning. It's just with so many people, it's too hard to manage people turning in homework late. Okay, so get it in on time, and if you don't, then that'll just be one of the ones that gets dropped, and it won't affect your grade unless you're doing that a lot. Okay, so we will drop a few for things out of your control. Okay, homework will be graded primarily on presentation, organization, neatness, completeness, and then a little bit for accuracy. Okay, so turn in professional, neat, organized work, and you'll get most of the points. And complete work. Okay, so complete. You got to complete everything too. Okay, quizzes. We're going to do in lecture. We're going to do quizzes once a week, 15 minutes, and I am going to actually post the quiz or something similar to the quiz before, so you'll have it. Okay. You'll have the quiz before, and then, or something very similar, and then we'll hand out fresh copies. You don't bring that to lecture, even though you had it beforehand. We'll hand out fresh copies, and you'll take that quiz 15 minutes once a week. I'm thinking Thursdays, but I'll make sure that that's what we want to do. Top hat questions will be often. Most days we'll have top hat questions. That's the in-class questioning system. Okay, again, here's the summary of the test dates. Final exams, Tuesday, December 5th, 7 p.m. Not December 5th. Let's see, that's May. Okay, attendance, gotta come. So all that, those paragraphs there say, come to class. That's what they say. Participation. Participate in class. Be engaged. All right. It's not, again, you're not sitting back and no one's sitting back and watching, and we will call you on that if you're doing that. Okay. Here's how the grade breakdown will go. Everything's important. Homework and web work. Just what happens in lecture, quizzes, top hat, attendance is worth 15% of your grade. All right. Exams are 45%. Finals worth 20%. Recitation does not have a weight in the 100%, but there's penalty for absences, and you can read about that there. So if you miss, your course grade starts going down when you start missing recitation. So just attend recitation, okay? All right, that's how I'm going to assign letter grades, and then this is all standard fine print. Withdrawal, honor policies, acting up on honesty. Any questions?
Does recitation start this week?
Yes, go to recitation this week. Absolutely, go to recitation this week.
I noticed the syllabus said no cell phone use, but if you have Top Hat on your smartphone, is that?
Oh yeah, no. Top Hat. Most of you will be using use smartphone through Top Hat.
Okay.
Yeah.
For the final, if you have a final right before that, then it's 7. Is that something
You can talk to me, but it's scheduled for 2 hours. Our final scheduled for 2 hours, but because it's at night, we can stay later. So if you show up a little bit late, that's okay. Other questions in the back?
As far as regularization exams go,
Nice and loud?
As far as regular exams go, I have a class that I got at 7:15, and I show up at 7:30 to take that.
Yes. Yep. Absolutely. Okay, so that's the syllabus. You should download it, print it out. Note that change that I made. I think I made it on mine, but not on yours. The final exam is in May, not December. No. Okay, so it would not be incorrect to say that calculus is, in a word, is a course about quantities. That would be an accurate statement. What is calculus about? It's about quantities. So instructions on a drink mix container say that 12 tablespoons of powder should be mixed with 50 ounces of water. So what are the quantities in this situation? What are the quantities in this situation? Yeah. Powder. Powder and water. What do we think? Matt wants something else. Go ahead.
Number of ounces of water.
Number of ounces of water. Other suggestions? What are the quantities in this situation?
Wouldn't it be the tablespoon example, like ounces?
Tablespoons and ounces. Okay, okay, go ahead. Number of tablespoons of powder. All right. Wow, no one said 12 and 50. So, okay, so all of your answers were on the right track. That by quantities in this course, we're not going to mean numbers. We're not going to mean values. We're going to mean some type of measurable attribute, measurable characteristic. So they're right. So like the amount of powder. The amount of powder is the quantity, not 12. 12 isn't the quantity. 12 is the value of that quantity. Okay? The amount of powder is the quantity, and the other quantity is the volume of water. When we define variables for those quantities, we also are going to need something else. What will we need? We're going to need units. If we call, say, x is the amount of powder, well, now x is taking on a value, so we're going to need to know what unit we're using. Okay? But just as a quantity itself, just the amount of powder, volume of water, that's fine. But if we define a variable, we're going to need the units as well. But the numbers, 12 and 50, are values of those quantities. Okay? So that's what we're going to mean. Whenever we talk about quantities in this course, that's what we're going to mean. We're going to mean something that's measurable about something. An attribute, a characteristic that's measurable. Volume, amount, height, speed, temperature, density, work. These are all types of quantities. Okay? Okay, so how can we model these quantities with an illustration? So this may be different than something you've seen before, but we can use what we call a bar diagram. Okay, so we can use bars to model this illustration. And so then each bar is representing a quantity, and the length of the bar is representing the value of that quantity. Okay, so what is our first, which quantity should our first bar be? Say, volume of water. Okay, and so then let's use, that's in ounces. Ounces is actually weight, isn't it? Isn't it ounces weight?
Yeah.
So let's see.
Fluid ounces.
So is fluid ounces still weight? Is that weight?
Fluid ounces is volume.
Fluid ounces is volume. All right, so we can say.
Water, they have equal values. So.
Okay, so volume was okay if we do fluid ounces.
Yes.
So we'll stick with volume. But we could, so yeah, that's probably what we want. Okay, and then the amount of powder in Okay, so then how long is that bar right now? So I'm sorry, the volume of the water, this volume of water bar. If we're representing this situation with these bars, then the length of that bar is 50, and the length of this bar is 12. So as you're doing your homework in the next week or so, we're going to see lots of these bar diagrams, and let me just emphasize that this is not about learning bar diagrams. Bar diagrams are just a way of representing what we really want to learn, which is about what? Quantities, okay? So try to keep that in mind. So when we do a bar diagram problem, it's not like, okay, I got to memorize those steps, so when I see one just like it, I'm going to do the same thing. No, it's about giving us a kind of a medium or a forum to talk about the quantities. That's all it is. It's just a way to help us represent it and understand it. So try to keep that in mind. So every time you come to and you want to use bars, you're thinking new. You're thinking, I'm going to represent this particular situation, not try to match it with something I've done before. Okay? So here's a question. How many ounces of water should be mixed with 4 tablespoons of the powder to achieve the right taste? Okay? So from your math experience, a question like this might conjure up this thing right here. You might think, oh, I'm going to do this. It's just proportions, right? Proportionality. And then what am I going to do? A times D equals B times C. And I'm going to solve for the one I want. Okay? We're not doing that. Okay, so this is just mostly this is a procedure that you've memorized, and you recognize that this procedure will work on this question. We don't want to do that. Instead, we want to use the bars to reason through this. Okay, so we're not just blindly throwing numbers at fractions and doing some operation to get an answer. So use the bars to reason about this. So think through this for a moment, and maybe talk to the person next to you. How can you use the bars to kind of reason through how many ounces of water we would need to have the right taste? So introduce yourself to the person next to you and talk about it. Go. This would make the right taste. 12 tablespoons of powder with 50 ounces of water. That's what the instructions say. So now we're going to have 4 tablespoons of mix.
I was thinking of like a scale, like bars. I don't know.
12 is 24%. 12 is 24%.
Okay, and then it's a big class, but I'm going to be calling on you, so be ready. Okay, so where's Josh Metz? Hey, Josh. How's it going? I had him last semester. Okay, so what do you think? What'd you talk about? Didn't understand it. Okay, let's try someone else. Where there's Price. Van Dam. I'm going to learn your name. So, oh, there's Price. Okay.
Well, we talked about, because it's 4 tablespoons of mix, there's, 4 into 12 is 3, so we take a third of the lower bar.
Okay, so you're looking at this bar and you're thinking a third of it?
Yeah.
Okay, so maybe something like this right here.
Yeah.
Okay.
And then matching it up to maybe a third of the bar above.
Okay, so if we were taking a third of 12, then we're also going to take
A third of 50.
third of 50.
50 is not divisible by 3, so it's a decimal.
Okay, so this will be 1/3 of 50. Valid way to think about it?
Yep.
Is it anything remotely like this?
No.
Remotely maybe. Okay, but it's a totally different way of thinking than setting up an equation and solving it mindlessly, right? So we're actually thinking about what's going on. We're taking a third of 12. 4 ounces is a third of 12 tablespoons. Sorry, 4 tablespoons is a third of 12 tablespoons. So we also need then a third of 50 ounces. And how do you calculate a third of 50 ounces?
Divided by 3.
50, so yeah, so you could say 1/3 times 50 or 50 divided by 3. Okay, what about that for an answer? 1/3 times 50. Can that be the answer right there? Okay, so if I said ounces?
There's no unit.
Okay, how about 1/3? How about that as my final answer? Is it okay?
It's not simple.
Is it valid? I'm not asking if it's comfortable or uncomfortable. I'm asking if it's valid. Okay. All right, so it may be uncomfortable because you want to get that final number, right? But this is just as valid as what you would get if you put that in your calculator. In fact, this is going to be you have to, if you use your calculator and get a decimal value, you're going to have an approximation because you're going to have what is that? 16.66667, okay?
Correct.
So this is actually exact. And what else is another advantage to this besides being exact? 1/3, reporting the answer that way. What's another advantage to that?
You get to see the setup.
Okay, yeah, Adam. Right, it kind of reveals your thought process, right? It shows what happened, right? It shows what happened. You were taking a third of 50 ounces. Okay, so reporting an answer like that is totally valid. In fact, I want to encourage it sometimes. Okay, remember what these bar diagrams are about. They're about giving us a means to talk about and reason about quantities. Okay, same setup. Instructions on a drink mix container say 12 tablespoons of powder should be mixed with 50 ounces of water. Okay, now I want you to use the bars to solve and illustrate how much powder would be required for 180 ounces of water. Okay, so I'll just give it, so you're going to work on this. If you've got your whiteboard, use it, okay? If you've got your whiteboard, use it for these. But I'll just one kind of thing here in advance. This one's a little different. This is a little different, so I'm going to leave it up to you to see how you want to use the bars. It's a little bit different now, okay? Go.
too bad.
Yeah. Because it's actually going to be 3.6. Yeah. Okay, alright. I'm so sorry. I'm so cute. I'm overthinking. Okay. Alright, so yeah. Like, oh, this is too easy. Wow.
Then do multiply by 12.
Yeah.
Ah.
Okay, Brianna. Sorry. Wait, hold on. 3 times 36. 36. So 36 balance and then a little bit more
Less.
so 30 5 6 yeah.
Lots of calculations, but I'm just using the bars. Using the bars. You set it up this way. It's not going to be able to do it. Question mark there is for a reason. Okay, so the point is to use the bars. Okay, so I see calculations, and many of them are probably correct. How can you use the bars to reason about this? Okay.
No, not really. He's going to be adding stuff to the first one on his island, but there's going to be like along the content.
No, you got it right. That actually,
In the team.
what you know, both got is 49.6. Because what you did first is you're calculating how many times
Yeah, say this.
Okay, is that
it's,
180 and 50.
and then you times
not
that
not
by
just
12.
that, it's also more of like the quality of yeah. Yeah, and it's all a matter of effort, and the tests are all on one subject. It's insane. I have a lab every Wednesday. My lab starts at 7:30, so I would either have to reschedule. No, that's not.
Okay, what's the problem with trying to use the bars this way in this problem? What's that? It's not 180. Well, what about 180? So if we wanted to show 180, then...
You would have to change the scale. Yeah.
But if I was, yeah, right, exactly. If I was doing this, how would I have to show 180? What would 180 be? It'd be like over here, right?
Yeah.
Be off the screen. Okay? So what can we do instead?
Make the amount of powder smaller.
If I want to use this bar diagram, then so rather than 50 ounces of water, so this is my volume of water. Make it 180, right? Make it 180 because that's the largest value. So then now I can think about portions of the 180, and I'm not off the screen, right? That's what I was trying to gets you to see there. If you throw a 50 and a 12 up there, then you're not really able to use your diagram unless you've got a lot of paper off to the right. So that's why I said not convenient. So yes, so you could do that, but then you need all that paper to extend them and show them longer. That's okay. That's valid. But here I have to do this because I'm limited in my screen space here. I've got to start that at 180. Okay, so then if this is tablespoons amount of powder, how long is that bar? Or what does the length of that bar represent? That's like the answer, right? That's the answer now. So now the answer is going to be the length of that, the corresponding amount of powder to 180 ounces. Okay, so it's here. Where's Lydia? Sakala. Lydia? Did you set it up this way?
Yes.
Okay, so where did you go from here?
So I'm looking. I divided 180 by 50.
Okay.
So I calibrated the first line. So there was one dot that represented the 50.
Okay.
Of 50.
About there?
Yes.
Okay.
Then the second one, another length of 50.
Okay.
And the third one, another length of 50.
Right.
Then the fourth one was a length of 0.6 times 50.
Okay, good. So she's saying that how does 50 relate to 180? That would take 3 and what would this be? She's saying it was 0.6 of 50. 3/5 or 0.6. Yeah, so I'll use, she said 0.6, that's fine. Is that what you, okay, and then where did you go from there?
Then from there, I did the same with the second line.
Okay.
I divided, yes, so the first line, the first distance was 12, the second another 12.
Good, so if that same portion at 50, whatever portion of 180 is going to be the same, 12 is going to be that same part of the amount of powder we need. Okay, good. So you said 12, and then 12, and then?
Then 0.6 times 12.
Is your reasoning valid? Does this work? Cool, so then all we need is, so what do we really, so how much powder do we have then? How much powder do we have? Keep going, you're doing great. So how much powder do we have then?
Oh, 43.2.
Okay, and where did that come from?
I simply multiplied, or I added the different parts.
Okay.
12 plus 12 plus 12 plus the 0.2 times 12.
Right, so we have, so how many 12s do we have? So yeah, she added these up, that's great. How many 12s do we have? 3.6 of 12 tablespoons. And what operation is that to get the answer? Yeah, we want 3.6 of those, so 3.6 times 12. So we recognize that there's 3.6 or 3 3/5, 50 ounces of water in 180 ounces of water. Therefore, we're going to have 3 3/5 or 3.6 12s to get the amount of powder. Same breakdown. Questions, comments? Okay. So let's talk about operations, okay? Operations. What operation results in a magnified or shrunken version of an initial amount of a quantity? What operation would result in a magnified or shrunken version of an initial amount or quantity? Addition, subtraction, multiplication, division. This is the result. This is the answer. You're going to do this operation and you're going to get, your result is a magnified or shrunken version of an initial amount. It's multiplication. Multiplication. So let's see examples of that. Okay? So the number of checkers in 12 rolls is 12 times as large as the number of checkers in one roll. So let's just start with that one. So use the bars to represent that situation. What am I showing with this lower bar here? So what quantity are we talking about here? Number of checkers. And then we could say specifically, what number of checkers is this representing? How many rolls? That'd be like one for one roll. And what's our quantity for this one up here? What? No, the quantity. What's the quantity? It's number of checkers again, right? And so this one down here is showing number of. This is showing how many rolls? One roll. And this is showing 12 rolls, so you get 12 times as many checkers. So we're magnifying the number of checkers by 12. So we're taking the number of checkers times 12 to get this bigger amount of checkers, 12 times as many checkers. Okay, so you do this one, quick. So key is focus on the quantities. What are not the numbers, the quantities, the measurable attributes that we're talking about here. Go. So write down measurable attributes, the quantities we're talking about. Okay, where's Brianna Murray? Brianna, can you tell me, how did you label these bars? Length of the shadow. Valid quantity? And then?
And then the height of the tree.
Height of the tree. How'd she do? Okay, and so this is showing that the length of the shadow is 2.8 times as long as the tree is high. Okay, how about this example held up against this initial kind of premise that we had? Does this example show that what's going on right there? Yes or no?
Yes.
Kind of. There's a difference. What's going on here on the second one that's a little bit different than the first one? So what do we say? So we have some initial value of quantity and we magnify it, right? Like we had a certain number of checkers in a roll, and we said we took 12 times as many. So now what's the resulting quantity? It's still what? Number of checkers, right? What's different about this one? Is there a hand back there? Yeah. So that the quantities are different? Is that what you're saying? So, nice and loud. Sorry, nice and loud. Right. So, this is really kind of implying that you start with a quantity and you scale it, you magnify it or you shrink it, and you're going to end up with just a different amount of that same quantity, right? But this is a little different because we started with the height of the tree, and we multiply by 2.8 to get a different quantity. Yeah, they're both distance quantities, but it's a different quantity. Now it's the length of the shadow. So this one is kind of a different animal than what we started talking about. So what we started talking about is what we call, this here is what we call, this is called scaling reasoning. Scaling. A magnified or shrunken version of an initial amount. That's scaling. This is now talking about using multiplication, what? To get a corresponding value of a different quantity. Do you see how it's different? Here I'm using multiplication on a value of a quantity to get the corresponding amount of a different quantity. So we're going to distinguish between those two. Okay, so that's what I have on the next page here. Okay, so now the result, the corresponding value of another quantity, still could be used, multiplication can still represent that. Okay, and so that was that example that we just had. So we want to mix up. So in terms of the bar diagrams, we don't want to get fixed on a certain way that they have to look. Okay, so can we use now these bars I've given you now to represent this same situation? Okay, is it valid? And even could I say that this is still the length of the shadow, the top one? Is it okay?
Yeah.
And could this be the height of the tree? Oh, it's uncomfortable, isn't it?
Yeah.
Is it valid? What's that?
It's not valid unless we change the operation to division.
Unless we change it to division. Okay, so even if I switch them, is this bar 2.8 times as long as this one? No, it's not even 1 time. It's not even 2 times as long, right? So even if I switch them, you still got, so the way that you want to think about this, you still got some conflict there. So how is it that this still can be a valid representation of what is written above? Talk to the person next to you. This is a perfectly valid representation of what's written above. Talk about it. How can it be? How can this be a valid representation? How can you think about it so it's not uncomfortable anymore? Okay, go. Yeah. Okay. Yeah, so you really want that to look longer, right? Yeah.
This is right. Valid. Because I really can't.
Okay.
So the shadow is 2.8 as much as the tree.
That's right.
But let's take a look at the wording. Maybe there's something wrong.
But even if you put the height of the tree here and the length of the shadow here, this bar is not 2.8 times as long as that.
Can we make it unless we make it bottom?
Okay, let me volunteer. Anyone, can you can you make sense of this way that I've set up the diagram? How could you make sense of this way that I've set up the diagram? Any ideas? What's that? Not to scale, okay? So you're saying you compare the two bars. When you compare the two bars, they're not to scale. Yeah, go ahead. Okay, so they are to scale, but we're using different units on each bar. How about that? Yeah, okay, in the back.
Maybe if you change like examples, instead of like 2.8 times as long as height of the tree, say 2.8 as long as the tree, how high it is. So instead of like times, you say it's 2.8. That makes sense.
So you're changing the numbers to make it fit the diagram, kind of?
Well, yeah, I'm not changing the numbers, but take out the times. Take out the times, and then say 2.8 as long as height of the tree.
I think that's the same thing. I think that's the same thing, yeah. How about in the back? Oh, there are different times. Yeah. That's departing a little too far from representing. Great idea, though. Great idea, but that would be departing too far. So those are all good ideas. My thought was just what someone said at first. So if this is 28 feet, so the length of that is 28 feet. What's the length of the bottom one? According to this.
2.8 times
2.8
28.
times that? No. What? So can we do that without calculator? Or what height of tree would result in a length of shadow of 28 feet? 10. So it's valid by just accepting that the two bars have different scales. They have different distance for 1 foot. That's uncomfortable. You want them to have the same scale. And that's actually probably a better visual for them to have the same scale. But I just wanted to see, just kind of think outside the box, expand your mind a little bit. So a foot on this one is different than a foot on this one. It's okay. It's okay. So it's still, this bar diagram is still then showing this situation that a tree shadow is 2.8 times as long as the tree is high. Okay? It might not be how we choose to make it. You know, it's not smooth and clean, right? It's not really user friendly, but it's valid. Okay? Yes, sir.
You can mess with us like this in the test.
What's that?
You can mess with us like this in the test.
Mess with you. Okay. So this kind of reasoning is called constant multiple reasoning. When you're using multiplication to get the corresponding value of another quantity, as opposed to scaling when you're just magnifying or shrinking the same quantity. So we want to distinguish between those two uses of multiplication. Okay, so here's a new situation. A car travels 72 miles per hour for 4.6 hours. Okay, I want you to represent that with a bar diagram. So I'm just going to put a generic one up there. Here are the ground rules, though. Here are the ground rules. Don't use speed as a quantity on either bar. Don't use speed. And then, when you're done, so as you're working on it and when you're done, make sure you can identify if your diagram is revealing scaling or constant multiple reasoning and be able to explain it. Okay, but so the main rule is don't choose speed to be either of those two quantities. Okay, so there may be you may have different responses. Do something that makes sense to you as long as you can explain it as either scaling or constant multiple. But there may be different ways with the rules I've given you, there may be different responses. Go.
All right.
So, They haven't written down quantities on the left. That's what we asked them. What quantities they can have your votes.
Yeah, as a quantity. Yeah, distance travel. The reason you said distance because distance over time is actually speed. It's not a quantity. Yeah. So that's it. This is 4.6 and this is 17, right?
You don't think so?
It is.
It's it's a constant multiple from the other constant multiple. This is scaling. So is it a constant multiple like this? Or is this scaling? No, because the constant multiple is like the one we did, which is not just scale. But this is scalar.
All using distance.
Speed isn't a quantity. Speed will be quantity, but you have to your quantity C, which is the number of losses calculations over time, which is 1.6. But this is scaling because whenever you walk, travel 72 miles, you're going to need 4.6 hours. It doesn't really, it makes sense. It's moving by what? At what? Let's see how much this car driving at. 45 miles per hour. 15. It's moving too slow. It's moving too slow.
What's that?
The car is moving too slow.
72 miles per hour. That's too slow. 72 miles per hour.
Oh, never mind. So,
Okay, so let's talk about some possible ways that you could have done this. Did anybody do this? The time to travel 72 miles and the time to make the entire trip. Anybody do this bar diagram? Is it valid? Okay, what would be the length of the bottom bar? And what would be the length of the top bar? Scaling or constant multiple reasoning? The scaling. We're scaling 1 hour by 4.6 to get 4.6 hours. Anybody do this? Distance covered in 1 hour, distance of the entire trip. Some people did this one.
I also did it.
Okay, so this one. So what's the length of the bottom bar? Distance covered in 1 hour.
Yeah.
Length of the bottom bar. 72. Distance of the entire trip.
72 times 23 over 5.
4.6 times 72, right? The scaling or constant multiple reasoning? Scaling. We're taking 72 miles and we're saying we're taking 4.6 of those. Another scaling situation. Most of you, I think, probably did this. Time to make the entire trip. Distance of the entire trip. What's the time to make the entire trip? 4.6. Distance of the entire trip? Scaling or constant multiple?
Constant multiple.
Scaling or constant multiple? Both.
Oh. Oh.
Look at this bottom bar. I could look at this bottom bar and I could say, these two bars can be thought of together as just the bottom bar. 1, 2, 3, 4.6. So in one bar, you can reason with scaling on one bar because it's the same quantity. Here's 1 hour. And then I can take that 4.6 times so that the whole length of the bar is 4.6 hours. That's scaling reasoning right there. And then I can do the same thing up here. I'd say 72, 72, 72, 72, and 0.6 is 72. So I'm in that top bar is this, right? That whole diagram right there, 72 taken 4.6 times, or 72 times 4.6. And so that's scaling there. But the whole diagram together is, you've got this 4.6, you multiply by 72, it gives you the corresponding distance of the whole trip by multiplying that 4.6 times 72. So those 2 points right there, corresponding values of different quantities. So by multiplying by 72, using constant multiple reasoning to get that distance of the entire trip.
That's scaling.
What's that?
That's scaling.
No, that's constant multiple.
But to get it, it's getting it down.
Constant multiple gives you the corresponding value of a different quantity. So in this case, the different quantity is distance. Started with time, multiplied by 72 to get distance. Constant multiple.